Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in removing all the half nodes in a binary tree. First, let us take an example. In the tree given on the left, nodes 7, 5 and 9 are half nodes. So, we remove them and we have the final tree on the right. Now, let us see the algorithm which will assist us in removing the half nodes. Let us also have a sample tree to test our algorithm. We pass the root node which is 2 in the function remove half nodes. So, root will point to 2. Since root is not null, we pass the left child to root's left using a call stack. Now, root will point to 7. Again, since root is not null, we pass the left child of 7 which is null. So, root will point to null. Since root is null, we return null. So, root's left of 7 will be null. We continue execution for node 7. Now, we pass the right child of 7 which is 6. So, root will point to 6. Again, we pass the left child of 6 which is 1. So, root will now point to 1. Since root is not null, we pass the left child of 1 which is null. So, root will point to null. Since root is null, we return null to the call stack. Now, we pass the right child of 1 which is also null. So, root will point to null. Since root is null, we return null to the call stack. We continue execution for node 1. Since root's left is null and root's right is also null, we return root. So, 1 is returned. Execution for node 6 is resumed. So, the right child of 6 is passed which is 11 and root will now point to 11. Since root is not null, we pass the left child of 11 which is null. Since root is pointing to null, we return null to the call stack. We continue execution for 11. So, the right child of 11 which is also null is passed. Since root is again null, we return null. Now, root's left and root's right are both null, so we return root which is 11 to the call stack. We resume execution for node 6. Since root's left and root's right are not null, we check if root is a half node. Since both left and right child of 6 exist, it is not a half node. And neither of the if condition is satisfied. So, we return root which is 6. We continue execution for node 7. Since right child of node 7 exists and left is null, the third if statement gets satisfied. Now, we create a new node, new root, which will point to root's right. We free memory for root which is 7. So, 7 will be deleted. We return the new root to the call stack. So, 6 is returned to root's left of 2. We continue execution for node 2. Now, we pass 2's right which is node 5 into the call stack. Hence, root will point to 5. Next, we pass the left child of 5 which is null. Since root is pointing to null, we return null to the call stack. we now pass the right child of 5, which is 9. So, root will point to 9. Since root is not null, we pass the left child of 9, which is 4. Again, we pass the left child of root, which is null, as 4 does not have any child. Since root is null, we return null to the call stack. We continue execution for the right child of 4, which is also null. Since root is again null, we return null to the call stack. We resume execution for 4. Since both left and right child are null, we return root, which is 4, to the call stack. Next, we pass the right child of 9, which is null. Since root is pointing to null, we return null to the call stack. Execution for node 9 is resumed. We check if 9 is a leaf node. Since it is not, we check if the left child of 9 is null. This is false, so we check if right child of 9 is null. Since right child of 9 is null, the last if condition gets satisfied and we create a new root pointing to 9's left. So, new root will point to 4. We delete the old root, which was 9. And we return the new root, which is 4, to the call stack. We continue execution for node 5. We check if 5 is a leaf node. Since it is not, we check if left or right child of 5 is null. Since the left child of 5 is null, it is not a leaf node and the third if condition gets satisfied. So we have new root equal to root's right, which is 4. We free the memory of old root, so 5 is deleted. Now new root, which is 4, is returned. Execution for node 2 is resumed. Since both left and right child of 2 exist, root, which is 2, is returned. We finish the execution of this program and we have removed all the half nodes. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.